All enzymes catalyzing reactions show specificity. The ability of an enzyme to choose an exact substrate from a group of similar chemical molecules is called specificity. Specificity of an enzyme depends on its own shape, charge, and hydrophobic or hydrophilic characteristics of the enzyme. So what is enzyme specificity? Based on the perception of function, it is the ability of an enzyme to choose the exact substrate. And looking at the process, it shows a molecular recognition mechanism. And it progresses towards the target based on the structural complementarity. So let's look at the various types of enzyme specificity. Bond specificity, optical or stereospecificity, group specificity, geometrical specificity, substrate specificity, and cofactor specificity. We are going to look at the main characteristics of each one of them. Bond specificity is specific to substrates having similar bonds and similar structures. Therefore, they bind to substrates that contain specific bonds only, such as ester bonds, glycosidic bonds, and peptide bonds. Example, alpha amylase enzyme can hydrolyze only alpha-1,4 glycosidic bonds in starch and glycogen, and not any other types of bonds. The next is group specificity. Here, the enzyme specific to the type of the bond and groups surrounding it perform the reactions. The enzyme is capable of acting only on molecules having specific functional groups like amino acids, phosphate, and methyl groups. Example is endopeptidases and exopeptidases. Group specificity is also referred to as moderate specificity or structural specificity. The next one is substrate specificity, also referred to as absolute specificity. Here, the enzyme is only specific to one substrate and one reaction. Hence, the specificity is considered to be high. Example, lactase acts only on lactose and maltase acts only on maltose. Optical specificity is also referred to as stereospecificity. Here, the enzymes are not only specific to the substrate but also to its optical configuration. Hence, the specificity is very high. For such enzymes, the spatial arrangement of the substrate is critical in determining if the enzyme will be able to catalyze the reaction. Example, L-amino acid oxidase can bind specifically only to L-amino acid. Geometrical specificity. Here, the enzymes can act on different substrates. The substrates must have similar geometry. Hence, the specificity can be less. Example, alcohol dehydrogenase can oxidize ethanol, methanol, and propanol to yield corresponding aldehydes. Cofactor specificity. This has greater specificity wherein the enzyme acts towards a specific substrate and cofactor. The reaction takes place if only the substrate and the cofactor match. If the cofactor is absent, the enzyme remains inactive. The process continues even though many substrate molecules are present.